Today we will start physics class with the chapter Unit and Measurement of class 11th. So what are physical quantities? Physical quantities are the quantities which can be measured like mass, temperature, velocity, etc. are called physical quantities. Physical quantities are of two types, fundamental and derived. Fundamental quantities are those quantities which does not depend on any other quantities. Like example, mass, length, time, temperature, etc. And derived quantities are those quantities which are derived from fundamental quantities like velocity, force, momentum, etc. When we measure any quantity, then we put an unit with it. Unit of any physical quantity is inversely proportional to its numerical value. So U is inversely proportional to 1 upon n, where n is numerical value of that physical quantity. When we use unit, for unit we have some system of unit on the basis of fundamental quantities. They are centimeter gram second CGS, meter kilogram second MKS, foot pound second FPS, and international system of unit SI. In SI system, there are 7 fundamental quantities and 2 supplementary quantities. These fundamental quantities and corresponding fundamental unit are mass. For mass, unit is kilogram. For length, unit is meter. For time, unit is second. For temperature, unit is Kelvin. For electric current, unit is ampere. For luminous intensity, unit is candela. For amount of substance, unit is mole. And there are 2 supplementary units like plane angle, unit is radian, and solid angle, unit is steradian. Whenever we talk about radian and steradian, for radian, plane angle is given by, let there is a circle and we take an arc S, and this is radius R. Then the angle formed at center will be equal to theta equal to arc upon radius, and unit will be radian. As we know that there is no particular unit, arc is just a distance and radius is also just a distance. So meter divided by meter, unit will be cancelled. So there will no unit, but we have a unit radian, which is supplementary unit. And we know that 180 degree equal to pi radian. Whenever we talk about solid angle, then it is something like cone shape. This is radius and this is solid angle, let d ohm. And this is area ds. In this case, solid angle will be defined as d ohm equal to area divided by square of radius, and unit will be steradian. If we take complete surface, then the area will be equal to 4 pi r square for spherical shape, and divided by radius square. So the angle will be 4 pi steradian. So for any object, by complete surface, the solid angle form is 4 pi steradian. Let's talk about the dimension. Dimensions of physical quantity are the power to which the fundamental quantity must be raised to represent the given physical quantity. It means that if we talk about example velocity or acceleration, A. Accelerations will be given by velocity divided by time. We know that time is a fundamental quantity, but velocity is derived quantity. So finding the dimensions, we have to write them in fundamental quantities. Velocity can be written as distance divided by time, like d divided by time, and there is one of time. Now distance is fundamental quantity, time is fundamental quantity, and this time is fundamental quantity. In this case, the dimension will be m. M means mass. There is no mass, so power will be 0. L. L means length or distance. There is 1, so power is 1. And T means time. There is 2 times time, so power will be minus of 2 as they go into up. This is called dimensional formula of the velocity, and the 0, 1 and minus 2, these are called dimensions of the velocity. Dimension of any quantity does not depend on system of unit. Whatever system you choose, like CGS, MKS, it does not have any impact on dimension. Pure number and pure ratio have no dimension. Like the number pi, it have no dimension. Some dimensions, same dimensions can be added or subtracted, but dimension will remain same. Principle of homogeneity of dimension state that for any physical equation to be correct dimensionally, dimension of its all term of both sides should be same. Like we have a formula of kinetic energy half mv square. Then dimension of this side and dimension of this side should be same. If this is same, then this equation will correct dimensionally. Now we will learn how to find dimension of any physical quantities. Like we choose an example of work or energy. For finding the dimension, we have to know the formula. Work is equal to force into displacement, F into D. Now, for finding the dimension, either you have to know the dimension of force and the dimension of length. Then you can do it directly, or otherwise we will write this in fundamental term. Like force can be written as mass into acceleration and distance. This is fundamental, but this is not fundamental. So again, acceleration will be given as velocity divided by time. Now this velocity is not fundamental. Again, velocity can be written as distance divided by time. So this will be m d square t square. Now all the quantities are in fundamental term. So we can now write the dimension as m l t. M is for 1 time, length is for 2 times, and time is for 2 times inversely, so minus 2. So this is the dimension 1, 2 and minus 2 of work. Now let's take another example and find the dimension of A and B in given relation P is equal to B minus X squared divided by AT, where P is power, X is distance and T is time. For finding the dimension of unknown quantity, we will use the dimensional, like there are two quantities b minus x square, they are subtracting. As we know, same physical quantities can be subtracted or added. So b should be equal to x square. And since x is distance, so we can write that the dimension of b will be L to power 2. Okay. Here the x is distance and the dimension of distance is L, and there is a square, so the dimension will be L square. Now, as we know that same dimension can be subtracted and added, and in this process the dimension will remain same. So the dimension of this term will be L square. In this case, P is equal to L square divided by A into T. Now we have to find the dimension of A. A equal to L square divided by P into T. Now write the dimension of power and time. The dimension of power is m1 L2 T minus 3, and for time is T1. Now solve this. Cancel. Minus 1 L to power 0 T to power 2. Minus 3 plus 1 minus 2, and when it goes upward it becomes plus 2. So the dimension of A will be minus 1, 0 and use of dimensional equation. As we know that dimensional equation of any physical quantity Q can be written as m to power A, L to power B and T to power C. This is dimensional equation of quantity Q, and here A, B, C is dimension of the quantity. Dimensional equation can be used as changing the magnitude of any physical quantity from one system of unit to other system of unit. And to check the accuracy of physical equation, establish relation between different physical quantities. Now we will learn this point separately. For changing magnitude of any physical quantity from one system of unit to other, we know that the unit of any physical quantity U is inversely proportional to its numerical value small m. So U n will be constant. If for any physical quantity Q in one system of unit is U1 and its numerical value is N1, then Q will be U1 N1. And if in another system of unit of that physical quantity is U2 and its numerical value is N2, then Q will be equal to U2 N2. So U2 N2 equal to U1 N1. As we know that the dimension of any physical quantity does not depend on unit system of unit, so U1 will be equal to M1 L1 T1 to power A, B, C, and U2 equal to M2 L2 T2 to power A, B, C. In this case, if we use this in this, then U2 N2 M2 L2 T2 power A, B, C equal to N1, M1, L1, T1 to power A, B, C. Okay. Now N2 is equal to N1, M1 divided by M2 to power A, L1 divided by L2 to power B, and T1 divided by T2 power C. Using this formula, we can move from one system of unit to other system of unit. Here N2 is the numerical value of the physical quantity in the system of unit in which we want, and N1 is the numerical value that given in the system of unit. Convert the unit of energy from joule to erg. Joule is in MKS and erg is in CGS. So we have to move from MKS to CGS. As we know the formula, N2 equal to N1 M1 divided by M2 to power A, L1 divided by L2 to power B, T1 divided by T2 to power C. For using this method, we have to know the dimension of work, which is M2 power 1, L2 power 2, T2 power minus 2. Okay. Now, in MKS and in CGS, here M1, L1, T1, M2, L2, T2. M1 will be in kilogram, 1 kilogram. L1 will be in meter, 1 meter. T1 will be in second, 1 second. And in CGS, M2 will be 1 gram, L2 will be 1 centimeter, and T2 will be 1 second. Now use this in equation N2, N1. Here we have to convert 1 joule to erg. So N1 will be 1. M1 is in kilogram. M2 is in gram to power A, 1. L1 is in meter. L2 is in centimeter to power 2 is second to power minus 2. Now always convert larger unit in smaller one. So 1 kilogram 10 to power 3 gram to power 1, 1 meter 10 to power 2 centimeter, and this will be cancelled, so don't use it. Now if we use this, then we get 10 to power 3 multiplied by 10 to power 4, or N2 equal to 10 to power 7 numerical value. Now if we use the unit, then it will be 1 joule equal to 10 to power 7 erg. Now take second use of dimensional equation to find the accuracy of any physical equation. Let's take an example. The frequency of sound produced in stretched string is given by small n equal to 1 upon 2L root mg divided by m. Here in this example, small m is mass per unit length, mg is tension. The dimension of this will be m1 L2 power minus 1 and m1 L1 T2 power minus 2. Now the dimension of both sides should be equal. So the dimension of frequency is t to power minus 1. 1 upon 2 have no dimension. So length have dimension 1 upon L1. Square root of mg have dimension m1 L1 t minus 2. Small m have dimension m1 L2 power minus 1. Now solve this. Minus 1 will goes up and become plus 1. So plus 1 plus 1 2 square root of L2 power 2 T2 power minus 2. Due to square root it become 1. Minus 1 and plus 1, this will be cancelled. So thus we have left hand side equal to right hand side. So we can say that this equation is dimensionally correct. Now we will talk about third use to establish the relation between different physical quantities. We have chosen an example. In simple harmonic motion, energy of any object E depends on the mass of object small m, frequency capital T, amplitude A, then derive the formula dimensionally. For this, we have to know the dimension of all quantities. Energy have dimension m1 L2 T minus 2. Mass have dimension m1. Frequency have dimension t to power minus 1. And amplitude have dimension L1. Now, as energy depends on these three physical quantity, so we have to write E is proportional to small m and A to power x, y, z. As now we don't know in the formula m, n and a where exist. It may be on upper portion, it may be on down. For removing proportionality sign, we will place a constant k. Now use the homogeneity principle of dimension. Left hand and right hand side should have same dimension. So dimension of E will be m1 L2 T minus 2. K will have no dimension. M have dimension m1. N have dimension T to power minus 1. And A have dimension Z. M to power X, L to power Z, and T to power minus Y. If we compare this, then we get X equal to 1, Z equal to 2, and minus y equal to minus 2 or y equal to 2. We use this in this equation and we get E equal to k m to power 1 n to power y, which will be 2, and a to power 2. So this is our relation.